we are going to be going over sections 3.3 and 3.4. Okay, so this is kind of like 3.1 and 3.2. 3.1 is pretty easy because you're graphing to figure out, well, let me take a step back. We're solving systems of linear equations, right? And 3.1 was pretty easy because if we have two equations in a system, right, and we want to find out where they're both true, we can graph them and find out where they intersect. And that is one way to figure out where they intersect is where both of them are true. And that's one way that we can solve systems of equations. So 3.1, we kind of get to use some technology, or we do get to use technology, right? It helps us graph, and then that allows us to figure out what's true. 3.2, if you remember, is when we solve systems of equations algebraically. So that's when we're actually plugging in the numbers and we're solving, like there's an example here, you can substitute one equation into the other. So we solve one equation for a variable, we plug it into the other equation, and then we get one equation with one variable, solve for that, and then substitute it back in. There's also the elimination method, where we have a common variable and we eliminate something. So that's kind of a review of where we are so far. Now we're going to go on to section 3.3. So 3.3 kind of takes us back to that 3.1 section, and we're talking about linear systems of equations. And I don't even know if this chapter is titled correctly, in all honesty. But these are actually inequalities. So I have my book right here. Well, it doesn't really matter. So what we're going to do in this section is similar to what we did in section 3.1. Okay, so what we have here is we have two equations, and we want to know what values are true for both equations. What's a little bit different about these two systems of equations is instead of having equal signs, we have inequality signs, right? In this case, y is less than or equal to 3x minus 2, and y is greater than negative x plus 4. Okay, so if you look at these two equations, we want to find out which x and y, or x's and y's, are true for these equations. Okay, so that's what we're going to do. Does anyone have any idea how we might be able to do it? You're like, no, that's why we came today, right? So yeah, the title of this, I don't know if yours is probably titled wrong. This title of this section is actually Graph Systems of Linear Inequalities. So for 3.3, you're going to need a graphing tool to do all of the homework. Okay, a graphing tool and then lots of graphs printed out would probably be helpful, or graph paper. So I'm going to use Desmos. That's only because I can't pull up a TI on here. You can use your TI for this. So also an option. Let me make it a little bigger here so I can see all the windows. All right, so for example, let's go to Desmos. Number one, we have y is less than or equal to 3x minus 2. So y is less than or equal to 3x minus 2. Okay. When I type this in to Desmos, there's a couple options that I have. I can use my symbols under here, under your keyboard. You can also just type in, like I literally typed in on my keyboard this, and then right after that I typed in the equal sign. And as soon as I hit the equal sign, it actually puts that underneath my inequality. All right, so what do we notice about this first equation? Well, it's a line, right? If I just typed y equals 3x minus 2, you get this green line that's along here, right? We have a line, but since it's inequality, y can be any value that is less than or equal to this equation. So Desmos is pretty smart, right? And it knew that it's a solid line because it can be equal to the points on this line. And then it can be any value that's shaded in over here. Okay, if you were using your TI, there we go. If you were using your TI, what you would do, if you were like using it for a test, you would just type in y equals 3x minus 2, right? You would get your line, and then you would figure out which side to shade. So I always, again, pick 0, 0. Does 0, 0, would that work in my equation? So if this is 0 and this is 0, is 0 less than or equal to negative 2? And it's not, so I'm going to shade this side in. Okay, so that's how you would use your TI calculator. All right, so I have one equation, right? Desmos does a little bit better job. And then I have my second equation, which is y is greater than negative x plus 4. Okay. So then if I wanted to know when both of these equations are true, what you're going to do is you're going to come over to your graph. I'll zoom out a little bit here. Okay. I'll even print screen it. Here we go. So if I was giving my solution to these two systems of equations that are inequalities, it would be, I need to think of another color that I'm not using here. It'll stand out yellow. So if I was drawing this on my graph, I would draw a graph that has a solid line here. Okay. And then here it has a dashed line. And then I would shade in everything over here. My amazing shading, right? So what does this mean? This means that anything that's in my lovely yellow shaded section, right? I can do a much better job shading here. Anything that's in my yellow shaded section should be a solution to both of these equations. Okay, let me make this a little smaller so I can see the chat. All right, so here's a question. Would x, when x equals 10, right here down here, when x equals 10 and y equals 0, is that a solution to both of these equations? What do you guys think?
Yeah.
No.
Everybody's afraid yes. Yeah, that's an answer, right? It's in my shaded section. And 10, 0 is one of the solutions. I can always plug this in, right? 3 times 10 is 30, minus 2 is 28. Is 28 greater than 0? Yep, that works, right? Over here, negative 10 plus 4 is negative 6. Is negative 6 less than 0? Yep, that's the solution, right? So anything in this yellow section is a possible solution. All right, so what about this green dot here? What about when x equals 0, y equals 10? Is that a solution to my system of equations? No, Otto says no. All right, oh no, yeah, Otto says no. I agree with Otto. That's not a solution, right? It works for my second equation, right? But it doesn't work for my first equation. So really, doing the homework here isn't hard to do, right? All of you guys are capable of typing into a graphing tool and figuring out, figuring out what the solutions are. But really understanding it is another thing, right? One last question. If I pick a point along this line right here, is that a possible solution to both my equations? If I'll do orange, different color. Is that a possible solution?
Yeah.
This is a possible solution because this line here is solid. So that means it can be an answer, right? I don't know what that exact point is, but if we flipped over to Desmos, it would be. On the other hand, if I pick this point here, which looks like 5, -1, I don't know if it is exactly 5, -1, okay? This one is not a valid point because this is a dashed line. So if this is 5, -1, it would not work, where this one is a valid solution. Okay, so what do you guys think? Would you be comfortable not just putting it in your calculator, but trying to figure out the solutions? Can you do it? All right, Otto says yes, that's good. Everybody else feel comfortable? All right, Anton says yes, great. Okay, so now I want you guys, I gotta find my window. While I'm finding my window, I want you to try, there we go. I want you to try graphing number 2. So x plus y is greater than -3, and -6x plus y is less than 1. Okay, so I want you to graph those two. Pull them up. I'm not going to put it up on my screen right away. I am going to I'm going to ask you a couple questions, and I want you to put in the chat if you think that these different points are true for both these equations or not true. So first of all, just go ahead and graph it, and then I'll tell you what to do. So let me know when you have it graphed. All right, so I'm going to assume you guys have gotten this graphed. Okay, so is anybody talking to me? I don't even know. Like, are you guys using your speakers or are you just using chat today? Looks
I've tried using the speakers. Are you able to hear me?
Olivia's talking and I can't hear her. So Olivia, I'm not ignoring you. I can't hear you. All right. I guess if you guys don't mind, I don't like doing this, but if you can chat back to me just for today till I get my microphone situation fixed up. All right, so we're on number 2 here. Hopefully you have them graphed. So I want to know in the chat, is this point 5, 0, is that a solution to this system of equations?
Yes.
Okay, Otto and Anton say yes. What does everybody else think? All right, Aaliyah says yes. Sounds good. All right, Noah says yes. All right, awesome. All right, now I have another question. What about -2, 0? -2, 0. Is 2, 0 a possible solution to both of these? I got 2 no's. Another no. All right, you guys are right. You're rocking it. Oh, sorry, Olivia. You can always text me. I'm sorry. I don't know what's going on with my headset today. Olivia can't chat back, so I promise I'm not ignoring you. All right, last one. What about 0, 1? Is that a solution to both of them? Nope. All right, you guys rock. So, perfect. Awesome. So I think everybody gets this. I don't want to just keep kind of going over the same things. That's the main idea of this section. There are, let's see, 10 problems. So honestly, the biggest probably difficulty in this section is printing out the graphs. All right, that's probably the biggest difficulty. There are some, like for example, number 23 and number 25 that actually have not just 2 inequalities, but they have, and not 3, they have 4 inequalities. So I just want to skip to example number 5 to kind of show you what that looks like. It's no different. You're doing the same things. You're going to put all 4 equations, or 5 or 6, into your graphing tool. Sorry, I just started typing. So this one's kind of cool. They're an artsy or more artistic. Okay. So for this, what you can see is that you kind of have to do a little bit of thinking about where do these all overlap. So what helps me when I do this is to kind of layer them. So here's my first equation, x plus y is less than 5. And then x plus y is greater than -5. So now the solutions that are true for both of these is basically this strip that's right here in purple. Okay, and then I add on x minus y is less than 4. Okay, so now I'm down to this kind of rectangle section up here. And then when I add in my fourth equation, I get a restriction over here. So really, the only solutions that are true for all 4 equations exist in this box right here. Okay, so 0, 0 is a solution to all the equations, right? But if I get out here to 5, 0, no longer a solution. So if I was sharing this in my homework, all right, if I open it up here, maybe. Not Excel. I don't know why I picked Excel. All right. Well, there it is in Excel, but that didn't really help me. All right. All right. Let's try this again. If I'm sharing this in my homework, Paint would be better. My homework would look something like this. I would have a coordinate plane. I would have a dashed line here and here. Like that. And then basically everything that's inside here would be shaded. my amazing shading skills in Algebra 2, right? All right, so any questions about that? It's kind of cool. We're basically figuring out where they all intersect. Thankfully, we don't have to do it algebraically. We're just going to do inequalities using graphing tools. So Desmos is a little easier for this particular section. Well, probably a lot easier for this particular section, but it wouldn't hurt if you have your TI just to try to kind of figure out, especially some of those earlier ones, if you can graph it without it. All right. So you guys feel like you can do these problems?
Yes, indeed.
Yeah. Definitely, definitely, right? Awesome. Okay. So that's the good news. Do the 3.3 homework first. And then 3.4 homework is a little bit more tricky. I shouldn't say it's more, okay. 3.4 is a lot of math. It's just a lot of details in math. It's not difficult, but there's a lot of work that goes into 3.4. Okay. So what 3.4 is that back in section 3.2, if you did your homework already, we were solving systems of linear equations when we had two variables, right? We had, well, let me scroll back up here. We had 5x plus 3y equals 20 and negative x plus 3y equals negative 4. So we had two equations, right? And we have two variables. We have x and y are variables. So two equations, two variables, we were able to solve that. Okay, now in section 3.4, we are going to learn to solve systems of linear equations with three variables. I can hear all of the cheering and applause now, right? Yay! All right, again, we're not actually learning any new methods that we did above 3.2. It's just kind of a more detailed process of what we're going to do. Okay. Let's see. So a couple things to note. You'll notice that we have systems of linear equations with three variables, right? We have x, y, and z. And because we have three variables, in order to solve this, we also need three equations to be able to solve systems of equations in three variables. Okay, so if you have two variables, you have x and y, and you want to be able to solve, you have to have at least two equations. If you have x, y, and z, three variables, you have to have 1, 2, 3 equations. If you had w, x, y, and z, you had four variables, guess how many equations you would have to have? You would have to have four equations, right, to be able to solve that. So we want to be able to solve these types of equations. And like I said, we're not going to use any new methods. Well, I shouldn't say. We're going to use the same two algebraic methods that we used before. So we're going to use substitution and we're going to use elimination. Okay. We cannot use for systems of three equations. We cannot use graphing. All right. So your TI doesn't graph in 3 dimensions. As far as I know, unless Desmos has made an amazing upgrade, it does not graph in 3 dimensions. So for these guys, you're going to have to rely on your algebra skills to kind of chug through. Okay, so what I want to do is I actually want to start with, it doesn't matter. Let's start with number 1. Okay, so we're going to use either elimination or substitution to solve these equations, and you could actually use a hybrid of each. Okay, so what you want to do with these types of equations, move this over here. What you want to do with these kind of equations is eventually we want to get all 3 of these equations down to one equation and we want to have one variable. That's what we're working toward. One equation with one variable. Okay, so we have three equations with three variables, and we're gonna use some of our algebraic knowledge to do this. So what I'd like to propose, what we try for this, is we're going to use, for this particular one, we're going to use all substitution method. Okay, substitution. All right. So what we're going to do is, just like we did in the other section, we're going to pick one equation and we're going to substitute it into the other equations. So I could solve either my first, my second, or my third equation for one of the variables. It doesn't matter which one we solve for. If I was going to solve my first equation up here, I would probably solve for y. If I was going to solve my second equation, I'd solve for z. And if I was going to solve my third equation, I'd solve for x. Does anyone have a very strong preference on if they want to solve for x, y, or z? All right, no preferences. I will pick. Let's solve for z because z is the hardest one for me to write. Okay, so what you're going to do is you're going to take your middle equation, and it does, like I said, if you're picking a different one, that's okay. You're going to take this middle equation and we're going to solve for z. Okay, so we have 6x minus 2y plus z equals -2. Okay, I'm going to subtract 6x from both sides and I'm going to add 2y to both sides. All right, subtract 6x and add 2y. And I end up that z equals -6x plus 2y minus 2. All right, so I know now that z equals -6x plus 2y minus 2. So just like in my 3.2 homework, right, I'm going to now substitute this in. I want to substitute, since I solved my second equation, I need to substitute this into my first equation and my third equation. Remember, you don't want to substitute it back into the one that you just solved, because if I substitute it into my middle one, you're going to end up with like, let's see, you're going to end up with 0 equals -2. No, you're going to end up with -2 equals -2, and you're going to think it's all real answers. So always substitute it into the ones that you haven't done. Okay, so my first equation, right, is 3x plus y, and then minus 2z. But instead of z, I'm going to plug in -6x plus 2y minus 2, right? Because that's what z equals, and that equals 10. So now I'm going to do some simplification. I have 3x plus y. I'm going to distribute my -2, right? So I have plus 12x minus 4y plus 4 equals 10. I have 3x and 12x, so I have 15x minus 3y plus 4 equals 10. Almost there. 15x minus 3y equals 6. Okay, so I substitute it into my first equation. This was equation number 1, right up here. I also have to substitute it into my third equation. So my third equation is x plus 4y plus 3z. But instead of z, I'm going to put in what I solved for z. 3 times negative 6x plus 2y minus 2 equals 7. Okay, I want to take a quick pause right here. Is everybody following? I know there's a lot of math, right? But is everybody kind of following along what I'm doing in general? Like what kind of the big idea behind it? All right, cool. Because I just don't want to get all like in the math. So let's kind of keep going. Keep chugging through here, right? X plus 4y. And then I need to distribute my 3, right? So minus 18x plus 6y minus 6 equals 7. Okay, so I have x minus 18x. So I have negative 17x plus 10y minus 6 equals 7. And if I add 6 to both sides, I get negative 17x plus 10y equals 6 plus 7 is 13. Okay, so now I have all of that work. Now I have 2 equations, and how many variables do I have? I have 2 equations, but I only have 2 variables, right? That's good, because now I'm kind of back to my homework that I did in 3.2. When I have 2 equations and 2 variables, I know how to solve this, right? I might not like how I'm going to have to solve it, but I do know how to solve that. All right. So anybody have any idea how we're going to solve? Now we went from 3 equations with 3 variables to 2 equations with 2 variables. Do you have any idea how I'm going to solve it now? Guess what? I'm going to use substitution again. All right, remember I'm doing all substitution here. So I'm making my paper magically longer. Now I have 2 equations, right? With 2 variables. This is the number 6 right here, not a b. The number 6, that would be helpful. All right, so if I want to solve 2 equations with 2 variables, I'll just write them like this. I have 15x minus 3y equals 6, and I have negative 17x plus 10y equals 13. Okay, these are my 2 equations now. So I want to solve one of these equations for one variable. I'm going to actually pick this right here. I'm going to solve for this 3y because I know if I divide 15 and 6 by 3, I get nice even numbers and I don't end up with fractions. You could solve for anything you wanted to. You'll just probably end up with some fractions. So try to be smart about what you pick, right? And we end up with, so we have 15x minus 3y equals 6, right? Subtract 15x from both sides, and we get negative 3y equals negative 15x plus 6. Then I'm going to divide everything by negative 3. And I end up with y equals 5x minus 2. Y equals 5x minus 2. Okay. Now I'm going to take that and I have to plug it in. I have to substitute it into my other equation, right? So I have to substitute it into this equation, my opposite equation. So we'll do that and we'll put that in green here. So now I have negative 17x plus 10y, but instead of y, I'm going to write in 5x minus 2. It's supposed to be a parentheses there, equals 13. Okay, all that work has led me to one equation, right? And I only have x in it, so that's really good. So I'm almost there, right? So I have negative 17x. I need to distribute my 10 plus 50x minus 20 equals 13. Here's where you're really hoping your numbers work out, right? What is positive 50x plus negative 17? 33x, right? And then I'm going to go ahead and add 20 to both sides. All right, so I end up with 33x equals, oh, look at this. 33x equals 33. Divide both sides by 3, and we get that. All of that to tell you x equals 1. Okay, when you get to the end here and you get x equals 1 or x equals 5 or x equals negative 2, you can just give yourself a big pat on the back, right? Yay! Because you know that you've probably gotten to the right point there at the end, right? All right, so are you done? Is the question. Yep, exactly, Otto. You still got to go back and figure out what y and z are, right? Thankfully, we've already solved for that. So if x equals 1, right here we know that y equals 5 times x, which is 1, minus 2. So y equals 3. So y equals 3. Okay, and then if I go way back up here, so I know x equals 1, y equals 3. Way back up here, I know z equals negative 6x plus 2y minus 2. So let me add on to my paper. Maybe. All right, so I know that z, way back from the top, equals negative 6x plus 2y minus 2. Right? So now I plug in my x and my y. So negative 6 times 1 plus 2 times 3 minus 2. So I get negative 6 plus 6 minus 2, or z equals negative 2. Sorry if that was loud on your microphones. Hopefully it wasn't as loud as me sneezing in your ear. All right, so that's z, right? Z equals negative 2. So now at the end of all this, your solution is going to look something like that. Like when x is 1, y is 3, z is negative 2. So this would be my solution to my system of equations. So what is this 1, 3, 2? By the way, this stands for your x, y, and z. Basically, you're always going to write your coordinates in alphabetical order. So if it's w, x, y, and z, then w would go in front of x. Right? A, B, C, D, it would be A, B, C, then D. So what this means is if I go all the way back up to the top with this equation, and I put in x equals 1, right, y equals 3, and z equals negative 2, and I put that into all 3 of these equations, this equation would be true, this equation would be true, and this equation would be true. okay? So that's what you're ultimately trying to do. You're trying to find when all three equations are true. There's just like a lot of math to get through to get there, right? So let me give you a couple tips. One is don't wait till the last minute to do this homework, because this section will take you a little while. Number two is there are some possibilities where you could get no solution or infinitely many solutions, but there's not that many examples. So don't think that every single one would be that. If you are stuck, I have done all of these problems. I've done most of the homework in the whole book, but in this particular section, I've done every single one. So if you are stuck, don't, kind of go back, look at your numbers. A lot of times what happens is someone along the way, and I've done this too, when you're distributing your -2 here, you'll forget to change this to +4, right? So be really, really careful when you're distributing and adding together that you come up with the right numbers. Because if I made a mistake way up here, it's going to throw everything off all the way through the rest. And then the last thing is, I don't want you to spend like hours on one problem. If you are stuck with a problem, send me an email or ask me in class on Monday or next Wednesday, and we can go through it. I might be able to kind of look at what you have, and then, or I will be able to look at what you have and say, oh, it's probably in this section where it got messed up. So it's a good kind of challenging section, but I know you guys can all do it. And yeah, so at least 3.3 is a little bit easy, right? You got 3.3 to kind of easy to get through, and then this section will be more detailed. And then, like I said, this is that hard section in the middle, and then we're going to start something new on Monday, which is matrices. Okay. If you do have a TI calculator, if you could bring it next week to class, that would be great, because we will probably use that. Okay, any other questions? Are you excited to do section 3.4?